The Mikoyan-Gurevich MiG-23 is one of the most iconic and technically advanced fighter jets to come out of the Soviet Union during the Cold War era. Designed and developed by the Mikoyan-Gurevich Design Bureau, it represented a major shift in Soviet air combat philosophy, a transition from the simple, lightweight fighters of earlier generations to a more powerful, multi-role combat aircraft with advanced radar and variable sweep wings. Introduced in the late 1960s, the MiG-23 became one of the first Soviet jets capable of engaging enemies beyond visual range, giving it a new level of versatility and combat dominance for its time. The MiG-23, known by its NATO reporting name, Flogger, was designed to replace the MiG-21, which had served as the backbone of the Soviet Air Force throughout the 1960s. However, the MiG-21's fixed delta wing design limited its operational range, takeoff and landing performance, and payload capacity. The MiG-23's engineers aimed to overcome these limitations by creating a fighter with variable sweep wings that could change their angle during flight. This unique design allowed the jet to perform well at both low and high speeds, giving it the agility of a light interceptor and the power of a long-range fighter. When the MiG-23 first appeared, Western analysts were both intrigued and alarmed. Its design was radically different from most Western fighters of that era, combining a powerful engine, sophisticated radar, and innovative aerodynamics. The aircraft was not only faster and more flexible but also more complex, signaling that Soviet aviation technology had reached a new level of sophistication. The MiG-23's exterior design is one of its most recognizable features. The jet has a sharp, aggressive profile with a pointed nose, large air intakes on both sides of the fuselage, and a tall vertical stabilizer. The variable geometry wings, perhaps its most defining characteristic, can sweep back for high-speed flight and extend forward for better lift during takeoff, landing, or dogfighting maneuvers. This system allowed the MiG-23 to operate effectively from shorter runways, a major advantage for Soviet forces during wartime deployments in remote or unprepared locations. The overall fuselage was designed with both aerodynamics and functionality in mind, ensuring a balance between speed, stability, and combat capability. The cockpit of the MiG-23 was another area of significant advancement compared to earlier Soviet fighters. The pilot's seat was positioned high for better visibility, and the canopy offered a clear view in almost all directions, crucial during dogfights. The interior layout was practical but efficient, with analog instruments typical of Soviet-era design. The cockpit featured an ejection seat system designed to protect the pilot during high-speed emergencies, and the ergonomics were improved compared to the cramped conditions of the MiG-21. The flight controls were simple yet responsive, designed to allow the pilot to manage the variable wing sweep system with minimal distraction during combat. In terms of avionics, the MiG-23 was equipped with one of the earliest pulse Doppler radar systems developed in the Soviet Union, the Sapphire radar. This system allowed the aircraft to detect and track targets beyond visual range, even against ground clutter, something Western aircraft like the F-4 Phantom II were already capable of. The inclusion of such radar technology made the MiG-23 one of the first Soviet fighters capable of firing radar-guided missiles, marking a huge leap in air combat capability. This meant that the MiG-23 could engage enemies long before they came into close range, which fundamentally changed Soviet air doctrine. The powerplant of the MiG-23 is another key element that defined its performance. It was powered by a single Kachatarov R-29 turbojet engine, capable of producing massive thrust, around 28,700 pounds with afterburner. This made the MiG-23 capable of reaching speeds over Mach 2.35 at high altitude, with an impressive climb rate and acceleration. The afterburner provided an enormous boost of power, enabling the jet to engage or disengage quickly in combat situations. The engine's design also allowed the aircraft to perform supersonic flight at lower altitudes, giving it a tactical advantage over many of its adversaries. However, the engine was complex and required careful maintenance, which sometimes limited the aircraft's operational efficiency in frontline conditions. In addition to its speed and agility, the MiG-23 had a robust weapons system. It could carry a wide range of air-to-air missiles, including both short-range and medium-range types such as the R-23 AA-7 Apex and R-60 AA-8 Aphid. The jet was also armed with a 23mm GSH-23L twin-barrel cannon mounted under the fuselage, providing a powerful backup weapon for close-range combat. For ground attack missions, it could carry bombs, rockets, and guided munitions, making it a true multi-role aircraft. The MiG-23's flexible design allowed it to perform as both an interceptor and a strike aircraft, capable of delivering heavy ordnance on enemy positions while still being fast and maneuverable enough for air superiority missions. Another impressive aspect of the MiG-23's engineering was its landing gear and airframe strength. The aircraft was designed for operations from rough airstrips and even temporary runways. The main landing gear was reinforced, and the nose gear had a strong shock absorber to handle hard landings. This rugged design reflected Soviet doctrine, which prioritized durability and adaptability in combat aircraft. The MiG-23 could take off from relatively short runways, which made it ideal for dispersed operations, a key strategy during the Cold War when airbases were potential targets for enemy strikes. The MiG-23's flight characteristics were often described as powerful but challenging. It was a pilot's aircraft, rewarding to those who mastered it, but unforgiving of mistakes. At high speeds, it was stable and fast, but at lower speeds or during aggressive maneuvers, it required skill to control due to its heavy airframe and sensitive wing sweep mechanism. Nonetheless, pilots who trained extensively on the MiG-23 respected its speed, climb rate, and ability to strike fast and hard. By the 1970s and 1980s, the MiG-23 had become one of the most widely exported Soviet fighters, serving with more than 30 countries worldwide, including Syria, Libya, Egypt, India, and several Warsaw Pact nations. It was produced in multiple variants, including interceptor, ground attack, and reconnaissance versions, each tailored for different mission profiles. The jet saw extensive combat service in various conflicts across the Middle East, Africa, and Asia, proving its effectiveness in both air-to-air and air-to-ground roles. While it faced Western fighters like the F-4 Phantom, Mirage F-1, and later the F-16, the MiG-23 often demonstrated formidable performance in capable hands. The aircraft's legacy is mixed but deeply respected among aviation enthusiasts and historians. Some Western analysts criticized its handling and radar reliability, while others acknowledged that it was a remarkable achievement given the technology and industrial capacity of the Soviet Union during its development. Its variable geometry design paved the way for future Soviet aircraft, such as the MiG-27 and Su-24, which used similar technology for multi-role missions. Despite the arrival of more advanced fighters like the MiG-29 and Su-27, the MiG-23 continued to serve for decades, especially in export markets where its combination of power, speed, and ruggedness made it ideal for nations with limited maintenance infrastructure. Even today, a few countries still operate upgraded MiG-23 variants for secondary roles or training purposes. As the MiG-23 matured, the Mikoyan-Gurevich design team continued to refine and evolve the aircraft to improve performance, reliability, and combat capabilities. Throughout its production life, which lasted from the late 1960s to the mid-1980s, the MiG-23 went through several major variants. Each new model integrated improved avionics, better radar systems, and structural modifications to enhance flight stability and endurance. These upgrades reflected the Soviet Union's commitment to keeping pace with rapidly advancing Western fighter technologies during the Cold War. The MiG-23M and MiG-23 megaliters were among the most successful variants. The MiG-23M, known as the Flogger B in NATO terminology, introduced significant radar improvements, allowing for greater detection range and tracking accuracy. It also received an upgraded R-29 engine variant, giving it more thrust and slightly better fuel efficiency. The MiG-23ML Flogger G took these improvements further by reducing weight, refining the airframe, and upgrading avionics for higher agility and better maneuverability. These enhancements transformed the MiG-23 into a more balanced and competitive fighter, capable of challenging Western aircraft such as the F-4 Phantom and early F-15 models in certain conditions. The MiG-23's variable sweep wing design remained one of its most sophisticated features. Pilots could manually adjust the sweep angle in flight, usually between three primary positions: 16 degrees for takeoff and landing, 45 degrees for general flight, and 72 degrees for high-speed operations. When the wings were fully extended, the jet had greater lift and stability, allowing for slower approach speeds during landing and shorter takeoff distances. When swept back, the wings reduced drag, enabling supersonic speeds and improved performance at high altitude. This flexibility gave the MiG-23 exceptional mission versatility, allowing it to perform both interception and ground attack tasks effectively. However, this innovative system also introduced complexity. The wing sweep mechanism required precise maintenance and could lead to handling difficulties during abrupt maneuvers. Some pilots reported that the aircraft could feel unpredictable at low speeds if the wings were not properly positioned. Despite this, the system represented a major step forward for Soviet engineering and showcased how the USSR was experimenting with advanced aerodynamic concepts to rival the West. Externally, the MiG-23 had a commanding and intimidating presence. Its sharp nose housed the radar system, while the air intakes on either side of the fuselage were carefully shaped to optimize airflow to the engine. These intakes featured variable ramps to adjust airflow at different speeds, preventing compressor stalls during supersonic flight. The single vertical tail fin provided excellent directional stability, and the rear fuselage was built to accommodate the massive afterburner section of the R-29 engine. The entire aircraft looked muscular, sleek, and distinctly Soviet, functional yet aggressive in appearance. Moving to the interior, the MiG-23's cockpit was designed with combat functionality in mind. It was not luxurious, but everything was built for efficiency and survival. The pilot's ejection seat, the KM-1M or later KM-1M2, was capable of zero-zero ejections, meaning it could be used safely at zero altitude and zero airspeed, a critical feature in emergencies. The analog flight instruments, though somewhat basic by modern standards, gave the pilot essential flight data clearly and reliably. The radar scope, weapons control panel, and radar missile guidance indicators were located within easy reach, allowing the pilot to transition smoothly between navigation and attack modes during combat. The canopy offered improved visibility compared to previous MiG fighters, especially over the nose section, though the thick framing somewhat restricted side and rear vision. This was a common issue with many second-generation fighters. Later variants improved this slightly by modifying the canopy structure. The interior lighting was dim green, suitable for night operations without compromising the pilot's vision. The control stick and throttle were mechanically linked to flight surfaces and engine systems, providing tactile feedback that skilled pilots learned to master over time. One of the most important features inside the MiG-23 was the radar and fire control system. The SAPFIR-23 radar allowed for all-weather operation and could detect targets up to 50 to 60 kilometers away, depending on conditions. This radar was linked with the aircraft's weapons systems, allowing semi-automatic target acquisition and missile guidance. The MiG-23 could engage targets using a combination of radar-guided and infrared-seeking missiles, such as the R-23R and R-23T. These weapons gave it the ability to fight both beyond visual range (BVR) and in close combat scenarios. The addition of the R-60 short-range missile made it deadly in dogfights, capable of locking onto heat signatures with precision. In addition to its fighter capabilities, the MiG-23 could carry a variety of air-to-ground munitions. Its underwing and fuselage hardpoints could accommodate up to 3,000 kilograms of payload, including unguided bombs, rocket pods, and guided missiles like the Kh-23 air-to-surface missile. This gave the MiG-23 impressive multirole flexibility, allowing it to serve as both an interceptor and a tactical strike aircraft. Some versions, like the MiG-23BN and MiG-27, were optimized specifically for ground attack, featuring armor plating, improved targeting systems, and reinforced landing gear for low-altitude strike missions. Performance-wise, the MiG-23 was formidable. With its powerful R-29 engine, it could reach speeds of Mach 2.35 at high altitude and climb to 60,000 feet within minutes. Its acceleration and climb rate were exceptional, allowing it to intercept intruding aircraft quickly. The aircraft's range was approximately 1,150 kilometers on internal fuel, extendable with external tanks. Though its endurance was less than some Western fighters, the MiG-23's role as a high-speed interceptor meant it rarely needed long loitering times. It was designed to take off, strike fast, and return quickly. The MiG-23's agility was more limited compared to later fighters like the MiG-29, primarily because of its heavier weight and variable geometry design. In close dogfights, Western pilots often reported that it could not outearn an F-16 or Mirage F-1. However, it compensated for this with its speed, climb rate, and powerful radar missiles. Soviet doctrine emphasized hit-and-run tactics, detecting the enemy, firing from a distance, and disengaging before close combat, and the MiG-23 was perfectly suited to that role. Operationally, the MiG-23 proved its worth in numerous conflicts. It saw combat in the Middle East with Syria and Egypt, in Afghanistan under Soviet forces, in Angola, and during various African and Asian regional wars. The aircraft's performance varied depending on pilot training and maintenance quality. In the hands of well-trained crews, it demonstrated deadly effectiveness, but inexperienced pilots sometimes struggled with its complex systems and demanding flight behavior. Despite this, the MiG-23 gained a reputation as a tough, reliable war machine capable of handling extreme conditions, from desert heat to rugged mountain bases. Maintenance and logistics were critical aspects of operating the MiG-23. While the aircraft was built robustly, its advanced systems, especially the variable sweep wings and radar, required specialized ground support. The Soviet Union provided comprehensive training and spare parts to its allied nations, but some operators found the upkeep expensive and labor-intensive. Nevertheless, many air forces continued to rely on it for decades due to its unmatched speed and power within their fleets. By the late 1980s, as aviation technology advanced, the MiG-23 began to show its age. New generation fighters such as the MiG-29 Fulcrum and Su-27 Flanker introduced superior avionics, aerodynamics, and fly-by-wire controls, making the MiG-23's older mechanical systems seem outdated. However, even as frontline service declined, the MiG-23 remained in secondary roles, including training, ground attack, and air defense for smaller nations. The aircraft's export success was one of the Soviet Union's greatest achievements in military aviation. Over 5,000 MiG-23s were built in total, making it one of the most produced variable geometry fighters in history. Countries like India, Cuba, North Korea, Libya, and Iraq operated it extensively. Some nations upgraded their MiG-23s with modern avionics, digital displays, and even new engines to extend their service life into the 21st century. The MiG-23's legacy in the aviation world is immense. It was a technological milestone for the Soviet Union, marking its transition from simple, lightweight fighters to complex, high-performance machines capable of rivaling Western counterparts. Its combination of speed, versatility, and ruggedness made it one of the most iconic aircraft of its era.